Lesson 6-4, Elimination. Our essential question today is how do you use the elimination method when you are not given opposites? So in lesson 6-3, we were given opposites right away, or we were given terms like 2x and then 2x where they were almost opposites. So today we're going to extend that a little bit further. So in this first system, it says use elimination to solve the system of equations. 6x minus 2y equals 10, and 3x minus 7y equals negative 19. So the question in green, how could we create opposites in this system? Because right now, at the beginning, we don't have opposites. But if you look at the x terms, 6x and 3x, you may realize that creating opposites with the x terms is going to be easier than working with the y terms. If I multiply the bottom equation by negative 2, that will give me negative 6x plus 14y equals 38. So remember that when you distribute, you have to distribute the negative 2 times everything so that you're not doing something that's going to mess with our equality, because the equal sign means both sides are equal to each other. So if you multiply one side by a number, you have to multiply the other side by the exact same thing. So now my top equation, I don't need to change it all because I now have opposites. Negative 6x and positive 6x would cancel out if we add together this system for elimination. So I looked at the x coefficients and the y coefficients, and I determined that 6x and 3x, because 3 is a factor of 6, I could multiply that 3 by a negative 2 so that it was the opposite of 6. So you just need to look at the coefficients to determine what you should do with your multiplication step before you can eliminate. Now, if I add together my y coefficients, positive 14 and negative 2, I get positive 12y equals 38 plus 10 is 48. This divides evenly, so y equals 4. So for my solution, I have found the y coordinate first. The y coordinate is 4. Now I can go back to either one of my original equations, or I could even use the one that I changed if I wanted to. I'm going to shrink this to get some space, and I am going to choose my top equation. So I'm going to take this top equation and I am going to use it with my value of 4 for y. So plugging in 4 for y looks like this. 2 times 4 is 8. To eliminate that 8, I need to add. So 6x equals 18. Dividing by 6 gives us x equals 3. So now my solution is 3, 4. The next problem, looking at coefficients again. 9x and 3x. 3 is a factor of 9, so I could turn it into a negative 9. Or eliminating the y's, I have y and then 2y. I'm actually going to eliminate the y's on this problem instead of the x's. Because if I multiply by negative 2, it's going to give me negative 18x minus 2y equals negative 26. So I like that even better. So now 2y and negative 2y would eliminate. 3x plus negative 18x is negative 15x, and negative 4 plus negative 26 is negative 30. Dividing by negative 15 gives me x equals 2. So on this system, I have found the x coordinate first. My x coordinate is 2. Now, I'm going to go back to one of the originals. Let's go with the top. Notice I'm going with the original equation on the top. So 9x plus y equals 13. And I know that x is 2. So 9 times 2, or 18. 18 plus y equals 13. Subtract the 18 on both sides, and y equals -5. So my system solution is 2, -5. I could have solved this system multiplying that bottom equation by -3 first to eliminate the x's. I would have gotten the exact same solution. I would have just been solving first for the y, second for the x coordinate. Okay, now look at this third system. 4x plus 2y equals 8, 3x plus 3y equals 9. How could we create opposites in this system? 4x and 3x. 3 is not a factor of 4. 2y and 3y, 2 is not a factor of 3. So what we have to do on this system is we actually have to multiply both of our equations right at the beginning to create our opposites. So I'm going to eliminate the y's. So that means if I multiply the top one by 3, I would need to multiply the bottom one by -2. Remember that they have to be opposites. They have to be opposites. So basically I took the coefficient of each one, the 2y and 3y, and I flipped them around, but I made sure that one of them ended up with a negative. So now my new equations. On the top equation, I will have 12x plus 6y equals 24. In bottom, -6x minus 6y equals -18. Now we're ready to add the system together, and I've eliminated the letter y. 12x plus -6x is 6x. 24 plus -18 is 6. Dividing by 6, x equals 1. So I have 1 for my x coordinate, and then I'm going to go with the top original equation. Remember, it doesn't matter. You've actually got 4 choices that you could go to. Either one of the originals or either one of the new equations would work. So, using the 1 from the top original, put in the 1 for x. 4 times 1 is 4, plus 2y equals 8, so it's a 2-step equation. Subtract 4, 2y equals 4, and then divide by 2, so y equals 2. So my ordered pair solution is 1, 2. We have one more equation that is like the last one, where it's going to be a little bit more work to create opposites. 6x and 4x, 2y and 3y, one of them is not a factor of the other. On this one though, I can do something a little bit different. I don't necessarily have to use the 2 and 3 like I did on the last one and reverse them. 6x and 4x I could turn into 12s. So it's kind of like you're looking for the least common multiple of the two numbers. The least common multiple of 4 and 6 is 12. So if I multiply the top one by 2 to turn it into 12, I would need to multiply the bottom one by not just 3, but -3. Because remember, one of them has to be a negative. So now my new system, my top equation is 12x plus 4y equals 4, and the bottom one, -12x minus 9y equals -24. Remember, there are going to be a lot of options for solving these systems. So you did not have to create 12 and -12. You could have eliminated the x's or the y's in an infinite number of ways, okay? So By going with the least common multiple, you will have a little bit smaller numbers to work with, and sometimes that's helpful. But if you don't think you're very good at least common multiples, you can always just take those coefficient numbers, flip them, and then make sure one is negative. Okay, so solving this system, my x's have eliminated. 4y plus negative 9y is negative 5y, and 4 plus negative 24 is negative 20. Divide by negative 5, and y equals 4. So I have the y coordinate first. Now, I'm going to go with my original bottom equation and substitute the 4 for y. Three times 4 is 12. To eliminate that 12, I subtract it. And then divide by 4. Negative 4 divided by 4 is negative 1. So my solution is negative 1, 4. You should be able to write a summary now. And here are your homework problems.